Hello friends, in surveying the last unit, unit 5, we are going to start curves and modern surveying. This unit can be split into two equal halves. One half is totally depends upon the curves and second half is based on the modern surveying or the advanced surveying. Right? The curves going to play a major role. We are going to see about the importance of curve, how we have to set out the curve. That portion is this first half. Second portion majorly about the latest equipment and latest methodology adopted for doing the survey. In the curves, we are going to have the introduction about it, theory and setting out methods of simple circular curve, elements of compound curve and reverse curve, transition curve, types of transition curve, combined curve, types of vertical curves. What is curve? Where we are going to use it? Why we need to know about it? What is the use of it? Why, as a civil engineer, I should know. Right? I hope the topography of a particular land terrain is visible for you. It comprises of major portion look like a flat terrain, but there is a road. It keeps on moving. The turn happens. It may be exactly 90 degrees. What will happen? Our ride or a drive, it won't be smooth. Accident will happen. So it has to be made very smoothly the turn. Right? For that, this portion is called the curve. The curve has to be settled out properly. So the sharpness of the curve has to be made properly. The sharpness of the curve again depends upon the radius of the curve. The radius of the curve again from where I need to place. For that, the approaches straights decide where it get meets, so where I need to set the curve and the limitations in the terrain. Right. So this is straight road, but it has a vertical changeovers, vertical. And this road there is a turn, and here turn curves. These turns and curves are not properly planned. What will happen? And this road straight can be directly made, but the terrain has some constraint. I need to go by this way, such a way that my ride or drive should be in smooth way also. See, there is such a super elevation in that road. I hope you may study in the transportation engineering. If it is not properly planned, what will happen? Right? So the alignment and this also again the curve. The sharpness here, the radius of the curve is very small. So the curves look like sharp. Right? Majorly in highway, 20 degree curves only they will maximum plan. Right? Beyond that they won't go. If it happen, the ups and downs of accidents will happen just like that. For in railway, it is more than that. Not even 20 degree, it is less than that. Since the train can't turn just like that. Right? So here see, there is a road, it gets turned, but we couldn't see the other side of it. So such steep curves are have to be constructed. So we need to know about the importance of the curve. Highway alignment, the center line of the road has to be maintained from the approach roads, and the meet out point has to be avoided by the smooth curve. Right. And the vertical, this drop, the sag has to be planned properly. If it is so deep, the vehicle can't travel. Right? So the components of highway design, the vertical alignment and the horizontal alignment has to be properly planned. So component of horizontal alignment, properties of simple curve, for that you have to understood. So the approach straight roads get meet at a point This has to be avoided such a way that the curve has to be provided. For this curve, these two straights become the tangent. Based on this tangent and the curve, now it is a smooth curve. The radius of the curve will be somewhere, origin will be there, longer. If it is a very sharp, the radius will be, so the radius decides the sharpness of the curve. And this is the S curve or the reverse curve, they will say, right? To avoid the minimum usage of area, the S curve they will plan. But if it is not planned properly, this is the most dangerous point, right? So proper planning has to be made. And again, I hope you have seen in the hilly roads, it is called the hairpin bend, and it is a type of curve. If it is not planned properly, this area, what will happen? Think about it. These are the roles we are going to play, right? And in infrastructure development, we need to avoid the traffic in the city, but we can't extend the area in a particular spot only. We need to make further, they keep on constructing the bridges with many turns and curves, right? So see here, it has a curve, it has a turn curve, it is a vertical curve. There are many turns. To avoid the usage of many space, and we can't extend also, so such that the bridges also, we need to have flyovers, say flyovers with proper alignment. There also curves play a major role, right? And without proper planning, if the curves are not smoothened, many accidents will happen in that bridges, right? So for smooth riding or driving, we are the major person. We have to understand the curve and the components of curve, right? The terrain demands, and there will be some limitations also. But the rider or the car driver, we can't travel just like that in ups and downs. There must be some comfortable we have to provide, right? The minimum, what are the comfort, that has to be planned based on the terrain also. Apart from that, railway track and train is a large vehicle and it can't turn just like that. So the sharpness of the curve is very sharp, such that the train has to travel very smoothly, and the passengers who are staying inside, they should not feel any discomfort also, right? These are the points plays a major role in designing highway alignment or railway alignment, track alignment. Everything has to be deals with the curve, right? Again, the picture for the curve change. Here the vertical curve, you are able to see the literally vertical. If this depth is so deep, the train can't lift, right? Since it is heavy. So for the vertical curve for the train and for the highway, it is totally different. So these difference and these approach or these components has to be remembered and understood properly. Right? I explained about this. Smoothness for the car is different and compared to the train. These are types of curves we can have. Curves, you split it the horizontal curve and the vertical curve. The vertical curve is simply divided into summit and sag or valley curve. Horizontal curve is again divided into circular curve, transition curve, or the combination of these two. Again, the circular curve is divided into simple curve, compound curve, reverse curve. Transition curve is divided into cubic parabola, spiral curve, lemniscate. Okay. So this is the simple curve for the two approach road or track. We need to make a small curve such that the radius of the curve is with the origin O, and the straights become the tangent for it. And the two straights gap is too far and the meet is also too long. I need to make it simple and smoother. So I need to have two pieces of curve with two different radius. For this portion, one radius, and another portion, another radius. So this portion's radius origin falls on the another one radius, and it looked like a same single curve, but the design only knows there is a two curves. So this is the compound curve, and this is the reverse curve, right? So for this curve, the radius is this. For this curve, the radius and the origin is this. We couldn't lay the road in the straight, but we need to make a smoother travel, the S curve, but proper alignment has to be made. I hope you understood the importance of curve, use of curve, where it going to be, in how it will be in highway, how it will be in railway, and the types of curve, right? I hope you will continue the